Okay, welcome to 4.1 notes. Hopefully, you're going to be able to get this and watch this off of Google Classroom while I am gone. Ask any questions. I will put the notes also online. On the back of your notes, I want you to create a little bit of space at the bottom of it because the first couple of slides aren't really on the front of this. I want you to create some space at the bottom. You should have it. It has some space at the bottom. And I'm going to go over some kind of just generalities. You should be able to remember this from Algebra 1, but if not, I want to make sure you get it, okay? So today, we're doing solving inequalities. We're going to learn about inequalities, how to solve them, and to graph their solutions on a number line. All right, exciting stuff. Here we go. The first thing that you need to remember is we're going to distribute if you have parentheses. I want to distribute if I have parentheses. The second one is I'm going to combine like terms on the same side of your inequality sign. Remember, when we combine like terms or simplify, it's always on one side of the equation, or in this case, the inequality. We don't start moving things. We want to combine or simplify on a side first. All right, and the third one is we're going to run PEMDAS in reverse, meaning we want to get rid of subtraction and addition first before we do division and multiplication. All right. Those are kind of the simple steps. Some other ideas. When dealing with inequalities, if we multiply or divide by a negative, we have to flip the inequality sign. So when you multiply or divide by a negative number, you must flip your sign. Flip the inequality. If it's greater than, then it becomes less than. If it's less than, then it becomes greater than. We have to flip the sign when we divide or multiply by a negative. Okay. What kind of signs are inequalities? Well, we should remember this from Algebra 1, but if not, the first thing we always want to remember is we want our variable on the left-hand side. So the variable has to be on this side. So if I'm using X, Y, Z, A, I always want it on the left-hand side. If I have this sign right here, what is that going to mean? Well, that means greater than. And it is red, X is greater than whatever is over there. So that is written as, or stated as, greater than. The next one, Y. Well, the other sign is, you guessed it, less than. So this means less than. Okay, so less than. The third one I have is the greater than sign with a bar underneath it. That bar means equal to. So I'm going to say it is greater than or equal to. Okay? It means greater than or equal to, and that is read as Z is greater than or equal to whatever is on the right-hand side. And last but not least, I would have less than or equal to. So less than or equal to. Less than or equal to. And these are our four signs. Remember, we always want our variable on the left-hand side. Even if we have to move it over there, we want it. Because when we graph these, we always want to read left to right. Okay? Left to right. Alright, so this is a little bit of vocabulary, kind of refresher from A1. Let's do some problems. The first one, I'm looking at the inequality, and it says write an inequality for each graph. As I look at this, I have a number line. And I have a solid circle. Well, with the solid means And I'm going to go back for a second. I want to go back. When I graph a greater than, I'm always going to use a open circle. When I graph a less than, I'm still using the open circle. The only time it changes is when I use a greater than or equal to and a less than or equal to. The equal to bar changes what it happens. And it becomes and I'm going to do it over here, it becomes a solid dot. So when I graph, it is solid. When I graph, it is solid. Just like a point when we do equal to, when we graph an equation, it's a solid dot. This is a solid dot as well. When it's just greater than or less than, it is an open dot. All right. So I look at this and I have a solid dot at -2. Well, how I'm going to write this is I'm going to write my variable and I can choose X, Y, Z, A, B, C. It does not matter which one. I'll use X to use it nice and simple. I am going to the right. I'm going bigger, -2 all the way forever. So this is going to be greater than. And what is it greater than? Well, it's greater than -2. But since it is a solid dot, it's not just greater than, it's greater than or equal to. Okay? X is greater than or equal to -2. The second one, I look at this and I have a open dot. I have an open circle. I'm going bigger once again, so I can choose my variable. This time I'm going to say Y. And I'm going to the right again. I'm going to the right, so that's going to be greater. And it's going to be greater than 6. I'm not going to say equal to because it's not a solid circle. It is an open one. The third one. I see an open circle at the number 5. And on the number line, I'm going to the left or going smaller. I'm going to the negative side of this. So I can choose my variable. This time I'm going to use the word or letter A, and I see it going left or going low, so it's going to be less than. And what is it going to be less than? Well, 5. It is less than 5. It's not equal to because the circle is open. And the fourth one, I have it a solid circle. I'm starting at 0 and going up or going bigger. So I'm going to say, let's say this. This is Y. I'll do a Y again. And then I'm going to be greater than 0. But I'm not just greater than. Since it's a closed circle, I am greater than or equal to. All right. So that's kind of a refresher on how to graph these number lines. Hopefully you remember this. Let's do some problems. The first one is I want to solve each inequality and graph its solution. Alright, so on the first one, I notice that I got a -2 outside the parentheses of 4 minus 7x, and that is less than a -120. So I want to go ahead and solve this. Well, I'm going to distribute. First, I'll write it. I'll write it down so you can see. I'm going to distribute the -2. Well, this becomes -2 times 4 is -8. And -2 times -7x is a positive 14x. Well, that is less than a -120. That does not change. Now, I look at this and I've got a -8, I got a positive 14x, and I've got a -120 on the other side. I know that I can add 8 to get rid of this 8 and move it to the other side because I want x's on one side and numbers on the other, just like I would do in an equation. So if I add 8 and add 8, I'm going to come up with 14x less than a -112. Now, if you're thinking, wait a second, he said something about flipping the sign. Remember, that's only when I divide or multiply. It's not when I add or subtract. Okay? So as I look at this, I got a 14x less than a -112. I would divide by 14, divide by 14, and that is going to be x is less than, we'll do the math. What is a negative 112 divided by 14? As you do it in the calculator, hope your calculator came up with the number negative 8. I know it's negative because that negative on top, make sure it stays negative. We're not changing because we divided by a positive, so a negative and a positive stays negative. So as I look at this, I want to read this from left to right. So x is less than negative 8. Find negative 8 on my number line. Open circle because I am just less than. I am not greater than or equal to or less than or equal to in this case. I know equal to on here. And I want less than, so I'm going to go smaller. So my graph goes this way. So I've solved the inequality. X is less than negative 8. And everything less than negative 8 would make this inequality true. Because remember, we're trying to make it true, right? So every solution less than negative 8 is always going to make this a true statement. All right, let's do another one. I have a negative 3k plus 2 times negative 5k minus 6 less than or equal to a negative 116. This one looks fun. I like this kind of a problem. So negative 3k plus 2 times a negative 5k minus 6 less than or equal to a negative 116. Well, one of the first things I notice as I'm doing this is I'm going to less than or equal to, right? So I know I'm going to have a solid dot. When I go to graph, it's going to be solid because I've got an equal to. First step I'm going to do is I'm going to go ahead and distribute. My negative 3k stays home. It doesn't do anything. It's just going to chill. It's going to sit on the couch watching television while the other people do some work here. 2 times negative 5k, so that's a plus a negative k, and that's a negative 10k, and then 2 times negative 6 is a negative 12, less than or equal to a negative 116. I want to combine my terms, and remember I do that on one side of the inequality here. In that case, I have a negative 3k plus a negative 10k. I could have written it as a negative 3k minus 10k. It means the same thing. This ends up being a negative 13k minus 12 less than or equal to negative 116. Now, I notice that I've got a k on the left-hand side. I've got numbers on the right-hand side of the inequality, but I still got a negative 12 here. I'm going to need to move that negative 12. I do that by adding to take it to the other side. This becomes a negative 13k less than or equal to, I added 12 to a negative 116, so this becomes a negative 104. Now, I have a negative 13k is less than or equal to a negative 104. Well, I notice that I'm going to have to divide by negative 13. I'm solving this just like I would. Divide by negative 13. That becomes k, right? Now, I divided by a negative. What do I have to do to my sign? You're right, I've got to flip it. So this less than or equal to becomes, and I'm going to do it in blue, becomes greater than or equal to, because I had to flip it to the other side. And a negative 104 divided by negative I can't speak, a negative 13. So negative 104 divided by negative 13 is positive 8. 8. You should have gotten that. So now my solution to this is k is greater than or equal to 8. And that would make this statement true. So I'm going to go ahead and graph it. I'll use red to graph it. So, solid circle, I've already seen that, at 8. So solid at 8. I want to be greater than or equal to, so the solid, I'm going bigger than 8 because I want to be greater than. And there we go. There it is graphed. All right. Hopefully you're understanding. If I'm going too fast, always, you know, you can pause this, slow it down, rewind, do any of that kind of stuff. All right, let's do a couple more. Number 7, I've got a -5 outside of 8x plus 8 minus 6 greater than or equal to a -366. That's a big number. All right. First thing I'm going to do is I'm going to distribute. I'm not going to rewrite it this time. I'm just going to start going. -5 times 8x is a -40x. -8 times 8 is a -40. Minus 6 greater than or equal to a -366. I want to combine like terms on this side. I have 1x over here, which is really a -40x. I have a -40 and a -6. Well, this is really a -40x. That can just kind of hang out for a second. A -40 minus 6 is the same thing as saying a -40 plus a -6, which is -46. And that's going to be greater than or equal to -366. I'm going to change colors here. Now, I'm going to add 46 to both sides because I want to get rid of that -46 on that side. That's going to leave me as a -40x greater than or equal to, what is that? That's a -320. Now, I'm going to divide by -40, leaving x by itself and a positive x. I'm dividing by -40. As I see this, -40 times divided by -40 leaves me just x. But I divided by a negative. I divided by the negative, so I've got to flip my sign. Flip it around. -320 divided by -40 becomes 8. So x is less than or equal to 8. Well, I know that it's less than or equal to, so I'm going to use a solid dot, and I'm going to have a solid dot at 8. Solid dot at 8. I am less than that or equal to, and the solid dot tells me I'm equal to, but I want to be less than. So I'm going this direction, and I would be done graphing. Okay. I want you to start number 8 on your own. See if you can do it. Pause it right now. Try it. And then come and watch mine and see if you did it right. All right, welcome back. Let's see if you got it. I have a -8 times 4x. It's a -32x. -8 times -3 is a +24. Greater than a -136. So I see this, I want to subtract 24. So I'm left with a -32x greater than, and -136 minus 24, so that's the same thing as saying -36 plus a -24. What is that? That's going to be a -160, I do believe, off the top of my head. Let me check my calculator. Yep, I'm right. So it's a -160. Divide by -32. Divide by -32. What does that do? What does that do? Well, if I divide by a negative, that means I've got to flip my sign, so all of a sudden it becomes less than. And checking my calculator, 160 divided by 32, because the negative and the negative becomes a positive, I have 5. So x is less than 5. I look at this, I do not have an equal to bar underneath, so when I go to graph this, I'm going to have an open circle. I'm going to have the open circle at 5. So here we go, open circle at 5. I want to be less than. Go in this direction. And there we go. All right, questions on that one? All right, let's move on. Here we go. The last two, okay? The big thing with this, and I'm going to write it at the bottom, and then I'm going to erase it here in just a second. When I see an OR, when I have two inequalities and I have an OR, that means either or. So if I see an OR, that means when I graph, I'm going to go this way and this way. I'm going to go either or, okay? I'm going to go either this direction or this direction. When I have an and, when I have an and, I am going to go like this. It's going to be between the points. So the line's going to be between the points. Okay? So my and is going to be between them. My ors are going to go one way or another. Okay? So make sure you've written that down so you know. And that's the easiest way to remember these. If I have an or, I'm going either, or, and I'm going together. I'm going together. Alright, I'm going to erase this, and we're going to move on. Okay, here you go. First one, 10a plus 4 is less than or equal to 34, or that is a negative 7a. Negative 7a plus 7 less than negative 42. Sorry about that. I have to solve both of these. I always want to keep my ors in between so I remember what I'm doing. So I always kind of write that. This is kind of what I learned when I was your age. I always wrote or in between. So I'm going to do these one at a time. First one, 10a plus 4 less than or equal to 34. I would subtract 4 from both sides. Gives me 10a less than or equal to 30. Divide by 10, divide by 10. A is less than or equal to 3. Okay? If I went too fast for you, knowing that you can always pause it and see that. Alright, the second one of these is a negative 7a plus 7 less than negative 42. And you're like, wait a second, they're both less than right now. I might find something funky here. Do the problem first and see what happens. You know or is going to go one way or the other, so somehow this sign is going to flip, okay? So trust it. First thing I do is I'm going to subtract 7 from both sides. That gives me a negative 7a is less than a negative 49. I'm going to divide by negative 7, divide by negative 7. Here's where we knew it was going to flip, right? Dividing by a negative makes my inequality flip to the other side, so it makes it greater than. And negative 49 divided by negative 7 becomes a positive 7. So I go to graph this. First thing I notice that this one is a less than or equal to. Less than or equal to a 3. And then I want to do that in red so you can see the same color. So it's a solid color. And it's less than or equal to. So I'm going this direction. And that kind of goes along with that idea that I already talked about, an either or, right? Now, this one is just greater than, so it's going to be an open circle at 7. But it's greater than, so I'm going this direction. Our graph ended up going exactly like I said it would. It's going to go this way or this way. The next one, the and. The and. If you're writing this down, I'm getting ready to erase it so I have some more room. So go ahead and pause it right now in case you don't have it all down. All right, here we go. I'm going to erase. Okay, let's look at this one. I got a negative 2v minus 6 less than or equal to 8. And I'm going to go ahead and write these down. And I don't want to forget them. And 2v plus 9 is less than 13. And I'm going to move this over just a little bit, running myself into a little bit of trouble. Let's do that. All right. So the first one, negative 2v minus 6 less than or equal to 8. Pretty easy one to solve. I'm going to add 6 to both sides because it was negative, leaving me a negative 2v less than or equal to 14. I'm going to divide by negative 2, divide by negative 2, leave me v. Since I divided by a negative, it becomes positive, and 14 divided by negative 2 is negative 7. All right, the second one. I have 2v plus 9 less than 13. 2v plus 9 less than 13. I'm going to subtract by 9. I'm going to have 2v less than 4. Divide by 2, divide by 2. 4 is less than 2. I notice that 1 is greater than and 1 is less than. That's what I want. I want them to be opposite signed. Okay? The ors had to be that way as well, but here we go. V is greater than or equal to negative 7. Greater than or equal to negative 7. So I'm going to be a solid, and I'm going to be greater than, so I'm going to go towards the middle. Okay, I'm not going to go too far yet. I'm just going to hold there. And V is going to be less than 2. Well, less than 2, open circle, and I know I'm less than. Well, the idea is they're going to meet. They're going to meet. So these go all the way in between. So there is an and. It is, the answer is, V is greater than or equal to negative 7, and V is less than 2. And it basically means that every number between there would work to make this inequality a true statement. All right, enjoy your Monday. I'll see you back on Wednesday when I get back.